Hi, my name is Armanisa Achari. In this video, I will explain 5 questions. Out of these, three will be theoretical and 2 will be practical. So let's start. First is, what is probability theory? Probability theory is a branch of mathematics that deals with quantifying the uncertainty of events. It allows us to predict the likelihood of an event occurring by assigning a probability value between 0 and 1. So key concepts of the probability theories are sample space, event, and probability of an event. What is sample space? Sample space is a complete set of all possible outcomes of an experiment. This means, let's take an example. If we roll a die, the sample space will be 1, 2, 3, 4, 5, and 6. Only 6 possible outcomes will be 6 possible sample space. And what is an event? An event is a subset of the sample space. An event could be a single outcome or a group of outcomes that we are interested in. Let's take an example. If we want to know the probability of rolling an event numbers, the event would be 2, 4, and 6. The three possibility only. Next, what is probability of an event P of E? The likelihood of an event happening. It is calculated by dividing the number of favorable outcomes, which is also called as sample space, divided by the total number of outcomes in the sample space. The total it is calculated by dividing the number of favorable outcomes, which is event, divided by total number of sample space. Let's say an example. If you roll a die and want to know the probability of rolling an even number, there are 3 favorable outcomes, 2, 4, and 6. And the total number of sample space is 6. So the probability of even number is 3 divided by 6, which is 0.5. So there is a 50% of chance of rolling an even number. This probability theory is used in the fields like finance, healthcare, gaming, etc. For example, insurance companies use probability to assess risk, while casinos use it to set odds in game of chance. Next question is, what are some common measures of central tendency and how are they calculated? First definition, what is central tendency? The central tendency refers to the statistical measures that identify the center point or typical value of a dataset. This measure gives a sense of where the most data points lie and provide insights into the overall distribution of the data. There are 3 measures in central tendency: mean, median, and mode. What is mean? The mean is the arithmetic average of a dataset. This is calculated by sum of all individual data points divided by the total number of data. This is the formula. The mean is sensitive to extreme values. Extreme values, which are also called as outliers, mean that a very high or very low number in the dataset can greatly affect the mean. Let's take an example. In this dataset, the numbers are 10, 12, 14, 14, and 15. So the sum of all values in the dataset is 65, and the number of values is 5. Thus, the mean is 60, total number 65 divided by the number of values, which is 5, equals to 13. So here the mean is 13. This is how we can calculate mean. Next is median. What is median? The median is the middle value of a sorted dataset. It is less affected by outliers. And for n odd numbers of data point, the median is central number. For an even number data point, it is average of two middle numbers. Like in this example, this set has odd number of data set, five number of data. So the median is 14. But next example, there are only four data, which is even number. So the average median will be calculated as the average of two middle point, which is 12 and 14. So the average of these two numbers is 13. So the median is 13. Next, what is mode? The mode is the values that appear most frequently in the dataset. It can be single value or more values, many values. So in the dataset, the same dataset, in the mode is 14 because 14 has appeared twice as compared to the other data. So practical applications, income data. For heavily skewed income data, the median income is often reported instead of mean value because of very few high earners can skew the average. And next will be test scores. Schools might use the mean to calculate the average test scores, but median might use when the scores are highly skewed and to avoid distortion by exceptionally high or low scores. Next question is, what is kurtosis? Kurtosis is a statistical measure that describes the shape of a distribution's tail in relation to its overall shape. It measures how much of data is in the tail compared to the center of the distribution. High kurtosis indicates more data in the tails, while low kurtosis indicate less data in the tail. The formula for to calculate kurtosis is like this: k equals to this formula, where n is sample size, x of I represents each data point, x bar is mean of the data, s is the standard deviation. Here, this high is leptokurtic. Kurtosis is three type: leptokurtic, mesokurtic, platykurtic. What is leptokurtic? Distributions with positive kurtosis. They have heavy tails and produce more outliers. Like this. They have heavy tails, high tails. This is leptokurtic. Leptokurtic distribution tend to have a sharper peak compared to a normal kurtosis, sharper peak. Example, financial markets often exhibit leptokurtic distributions because they tend to have more extreme fluctuations compared to normal distributions. For example, a stock's returns distribution may show a sharp peak with heavy tails, suggesting that extreme market movement occur more frequently than in a normal distribution. Next is mesokurtic distribution with zero kurtosis, which match the normal distribution in terms of tail heaviness and peak. The data has moderate tails and the peak is neither too sharp or too flat. Like in this image, the second, neither too sharp, neither too flat. This tail also neither too flat, neither too high. So, in practical example, scores on standardized tests like the SAT often follow mesocotic distribution, with most students scoring near the mean and fewer scoring very high, very low. Next is platyquote distribution with negative cortices. These distribution have light tails and flatter peak, meaning fewer extreme values occur. The data is less concentrated in the center, means the center will be is nearly like to the tail. Example, platyquotic distribution could appear in quality control processes where defects are rare, meaning there are fewer extreme deviation from the norm. In practical example, If you are monitoring the weight of a manufactured products, this distribution might be pretty cutting. If you, if most products are very close in weight, with very few being significantly heavier or lighter. Application of courtesies in finance. Investors and analysts often use courtesies to assess the risk of financial assets. High courtesies in asset return suggest a higher likelihood of an extreme outcomes, such as sudden gains or losses. In quality control field, courtesies can be used to evaluate the consistency of manufacturing processes. A low courtesies indicates fewer outliers and more controlled process. Next, this is a practical question. The question is like this: if there are a 30% probability that you will see a supercar in any 20-minute time interval, okay, what is the probability that you see at least one supercar in the period of an hour? Okay, first event. What is it? The probability of seeing a supercar in any 20-minute interval is P of a supercar in 20 minutes is equals to 0.30. To solve the problem, we need to calculate the probability of seeing at least one car in 60 minutes. To calculate this, next we need to follow the next step. Find the probability of not seeing a supercar in 20 minutes. Seeing a supercar in 20 minutes is 0.3. Not seeing a supercar in 20 minutes is 1 minus 0.3, which is 0.70. This is not seeing a supercar in 20 minutes. This we need to extend. Since this 60-minute period can be divided into three 20 minutes intervals, 20, 20, 20. We can now calculate the probability of not seeing a supercar across all three intervals. Not seeing. So P of no supercar in 60 minutes equal to P of no supercar in 20 minutes to power 3, which is equals to 0.7 to power 3, which is 0.343, which is the value P of no supercar in 60 minutes. Next, find the probability of seeing at least one supercar. The probability of seeing at least one supercar in 60 minutes is a complement of not seeing any supercar, which is 1 minus P of at least one supercar in 60 minutes equals to 1 minus P of no supercar in 60 minutes, which is complement. So 1 minus 0.343, which is 0.657. So the probability of seeing at least one supercar in a 60-minute period is approximately 65.7%. I have used in this problem, I have used complement rule, which is often useful when calculate the probability of at least one, at least two, this type of. It is typically easier to find. It is find the probability of the event not happening and subtract that from 1. I have used such concept in this problem. Next problem is, the question is, imagine that Jeremy took part in an examination. The test has a mean score of 160, mean is 160, and standard deviation is 15. If Jeremy's G score is 1.20, what would be his score on the test? So in this from this question, we get mean is 160, HD equal to 15, G score is 1.2. The we need to find the Jeremy's actual test score. So the formula of the G score is Jeremy's score minus mean divided by standard deviation. If we rearrange the formula to find the Jeremy's actual score, then we will get the formula like G score into standard deviation plus mean. Jeremy's score is G score. If we put the values in place of the formula, we will get Jeremy's score equals to 1.2 into 15 plus 160, which is equals to 178. So answer is Jeremy's actual score is 178. From this, we will get the mean 160, standard deviation 15, and G score 1.2. So G scores are a way to standardize individual data points by expressing them in terms of standard deviation from the mean. This is the G score. So this is all for the video. Thank you so much.